Hello AP Statistics students. In this video, we're going to take a look at stem plots. So again, we are going to be comparing distributions of quantitative variables, and we're going to create a stem plot and show quantitative data and then describe that data. So here's a quick example for this. It's already been done for us. So here we have data for resting pulse rates in beats per minute of 19 middle school students. Context, context, context. All right, we'll probably have to refer back to that later. So here's the raw data that they collected. And then what do you do with data? You make a picture. So here is our picture, a stem plot. They could have done a dot plot, but this time we're looking at stem plots. So hopefully you've seen one of these before, but if not, the main thing about stem plots is an accurate key, this right here, to tell you what all this information means. So the key says 8 bar 2 is a student whose resting pulse rate is 82 beats per minute. So the left piece over here, this is the stem. And this part over here on the right is the leaf. You may have heard these called stem and leaf plots before, but commonly known as just stem plots. And to know what those numbers mean in this graph, you have to have this key. So 8.2 is 82 beats per minute. Now that's necessary because 8 bar 2 without the key could mean two different things. It could mean 82. But it could also mean 8.2. So to make sure you know which one of these that means, the key is necessary. And again, context, context, context. The key does not just have this much. This is not a good key. It has to have the context. Is a student whose resting pulse rate is 82 beats per minute. You need to have not only the numbers and the math, but also the context. So the next part, according to the American Heart Association, a resting pulse rate above 100 beats per minute is considered high for this age group. We can see that 2 out of 19, or a proportion of 0.105 of 10%, have that. Now, can we find those two values on the stem plot? So right here, this is 104. That is this data point right here. And this one right here, 12 bar 0, is 120, following the key, which is this data point right here. Now, again, what does the picture allow you to do? It allows you to describe the distribution. So remember, to describe a distribution, we use the acronym SOX. We want to describe all of this. So the first S stands for shape. What shape do we see here? So it's turned on its side, yes, but hopefully you can still see the general shape right here. That is skewed to the right. If I would turn that up horizontally, that would be skewed to the right with a single peak at the 70s. You would call that the 70s stem. Okay. All right, that's shape. Outliers. Are there any outliers? We haven't gone to calculating outliers, so all we can say is maybe 120 is an outlier. It looks possibly that it's really far out there. So for now, you could say a possible outlier at 120. Where is the center? So that would be either your average or your median. So we could calculate the median. Where is the middle? How many pieces of data? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Oh, 19, duh. So if I'm going to have 19 pieces of data, that means I'm going to have 8 on this side. Sorry, 9 on this side, 9 on this side, plus the median in the middle. So I need to count over 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the next one is the median. So the median is 76. That would be our center. And spread, what is the overall variability of this data? Right now, one of the main things we have is range. So what is the range of this data? Well, the lowest point is 68, and the highest is 120. And so we can subtract those out, and you would get 52. So we have a spread, or a range, of 52 beats per minute. All right, so that's how a stem and leaf plot can help you describe a distribution doing all of socks. All right, let's keep looking and get a more thorough example down. So many athletes and their parents worry about the risk of concussions, as they should, when playing sports. A football coach plans to obtain specially made helmets for his players that are designed to reduce the chance of getting a concussion. Here are the measurements of head circumference in inches for 30 players on the team. There we have our data. Make a stem plot of these data. All right, now this is obnoxious, not gonna lie. Getting data that's out of order is a real pain. And so if I was gonna create a stem plot of this, the first thing I would have to do is order the data from least to greatest, greatest to least, doesn't really matter. But I did that for us here. All right, then to make the stem plot, you first have to figure out what are your stems going to be. So I'm gonna draw my line. I'm going from 20.8 all the way up to 25.6. So I think a good way to do this would be just start at my 20s, and then all my 21s, all my 22s, all my 23s, all my 24s, and then all my 25s. And so then each one of these here will be 20.1, 0.2, 0.3, 0.4, 0.5, etc. And then all my 21s. So the first two, 20.8, so it'll be 20.8, and then another 20.8. Now this part you want to try and space these out evenly for each one. That way your picture will show you the overall shape. Now 21, there is a 0.0 there, so I do need to put the 0.0. 21.5, 21.6, 21.7, 21.9, and now 22 is the next one. That's a 22.0, 22.2, 0.3, 0.4, 0.5, another 0.5, a 0.6, and a 0.6. 1, 2, 3 sevens. And now I'm on to the 23s. I got two 23.0s. 1, 3, 4. 5, 5, 9. Another 9. Now, am I lining these up? I got a little carried away. Yeah, they're pretty good. Let's see. Oops, did I put those in the wrong place? I did, didn't I? Lame. All right. 1, 3, 4, 5, 5, 9, 9. Those were all 23s. Wow. There we go. 24.0, 24.2, and 25.6. So there we have our stem plot. Next, I have to do the key. So put this in a box. Hopefully that's big enough. So I just pick any piece of data I want. So I'll go, let's say 22 bar, and I could pick any one. Let's go 4. Let's see here. What was is an athlete with, wow, a head circumference of 22.4 inches. If I could spell, that would be great. There we go. So there is my key. Now, what does it say to do next? Part B. Describe the shape of the distribution. So this question does only say describe the shape. Let's go ahead and do everything we know about this. All the socks. Shape, outliers, center, and spread. Just for practice. So first, shape. What do we see here? All right. The shape of, I might not say the shape of head circumference, that might be kind of mean. The distribution of head circumference is roughly symmetric. All right. That looks like the left or the top is the same as the bottom with a single peak at, now where is that single peak? At the 22-inch stem. Okay, the 22-inch stem, oops, is where the single peak is, right here. All right, we got shape. Now we need outliers. Are there any outliers here? And I don't think there look like there'd be any outliers. This shape, nothing seems to break from this shape. So I would say there does not appear to be any outliers. Now eventually, again, like I keep saying, we will calculate outliers, but for now we're just looking at it. All right, so now the C, the center. Where is the center? Well, because I ordered the data for you already, this is pretty easy. There are 30 pieces of data, and I put it into 2 columns, so it's between 22.6 and 22.7. There's 15 on the left, there's 15 on the right, so it's got to be between those. What is right between those? 22.65. All right, so we'll go here. The median head circumference is 65 inches. And our last one, which is the spread. So right now, the main thing we do for spread or variability is the range is a good one. So the range of head circumference for this team is, so now we got to take the max and the min and subtract them. So that is 20.8 is the lowest one, and 25.6 is the highest one. What is that? 4.8, I believe. Yes. So our range is 4.8. Is 4.8 inches. There we go. We used the stem plot to describe all of our, where did I put this word socks? There it is, socks. Shape, outliers, center, and spread or variability. All right, other things we can do with stem and leaf plots, okay? So here's that same one. I have a printed version of it that we just looked at for head circumference. But this looks a little compact. What if we wanted to spread it out? What you can do to essentially change the scale is to split the stems. So we have one stem for 20, 21, 22, etc. What we can do is space that out and put two 20s, two 21s, two 22s, two 23s. Hopefully I have enough space here. Two 24s, and then two 25s. The last one kind of fits. Sorry about that. Actually, I can fix that fairly easily, can't I? Oh, interesting. Let's try to undo that. Can I make that look a little better? Sort of. There we go. Now I've got space for my two 25s. Now, imagine this, instead of counting by ones, we're counting by 0.5s. Okay, so our first stem for 20, this would essentially be from 0 to 4, and the second one would be from 5 to 9. All right, each one of those has 5 digits, 0, 1, 2, 3, 4, and 5, 6, 7, 8, 9. So the first stem are only from 20.0 to 20.4, which we have none. The second stem is 20.5 up to 20.9, which we have 2, the 2 8s. All right, the next one, we're just going to take the 0, and then the 5, 6, 7, 9 go on the next one. 5, 6, 7, 9. The 22s, the 0 through 4 go on the first one. So 0, 2, 3, 4. And then all of these are on the second stem for 22 because they are over 22.5. 5, 5, 6, 6, 7, 7, 7. My next one I take all the way up to there. So 0, 0, 1, 3, 4. And then 5, 5, 9, 9. 24 has 0 and 2 right here, nothing here. 25 also has nothing in the first one, and then 1 at 6. And so here, hopefully you can see the shape is still roughly symmetric, but because we spaced it out, now it almost looks like there might be an outlier. This one looks pretty far away, so you might now say that 25.6 is a possible outlier. So sometimes you need to spread out your stem plot to see more information. All right, one more thing. Just want to show this to you. Hopefully it's pretty self-explanatory. Sometimes if you're going to compare two sets of data that are related somehow, you might put them in a back-to-back stem plot. So here the stems are in the middle, and one data set over here has its leaves, and the other one has it over here. So again, if you're going to read this, if I see 9 and 6, when I'm reading it backwards to the left, that might be a little weird. That is 96. But then the same thing over here, the 9 and the 5 on this side is 95. You only have to put one of those in your key. You don't have to put the left and the right because they should have the same scale and key. This one couldn't be 96 and this one be 90 or 9.5. That wouldn't be clear at all. But sometimes you will see that, and now you can compare both of those distributions to each other quite nicely. All right, that is stem and leaf plots. Hopefully that makes some sense. If not, certainly ask me some questions. Goodbye.